Geometry B, it's the home stretch, so we're going to try and cram the entire curriculum, all 12 weeks from the trimesters, into like 2 days. The first thing we're going to review is back in Unit 3. This is trigonometry. This is actually the end of Geometry B, Geometry A, and the beginning of Geometry B. The special right triangles, do you remember the labels? It doesn't really matter what variables you use, but I use S and S for the side of a square. This is an isosceles right triangle. It's the corner of the square. So I use S, S, and then the hypotenuse is S radical 2. We're going to do some problems with this later. The other one is if it's a 30, 60, 90, across from the 30 we usually call x, and across from the 60 is x radical 3. So whatever this is, you multiply by radical 3, and the hypotenuse is always 2x. If you remember your trig ratios, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. The way people remember this, SOHCAHTOA, if that helps, opposite over hypotenuse is sine, A over H, adjacent hypotenuse, O over A, opposite over adjacent. So those are your trig ratios. You should know those. If it says solve for x and y, and we say exact answers, that means we're talking about special rights. So we're using those triangles that we just talked about. If across from 30 is 4, that means that that is your x. So sometimes I'll even write it as like x equals 4, and then this is supposed to be x radical 3. So if that's 4, we're going to say 4 radical 3. And this is twice whatever this side is, so this is going to be 2 times 4, which is 8. So we have 4, 4 radical 3, and 8. This problem, if this is my 30 degree and across from that is 4 radical 3, that means I need to take 4 radical 3 and multiply by radical 3. Radical 3 times radical 3 is 3, so 4 times 3 gives you 12. This side would be 12, and since this is always twice, across from the 90 is twice what's across from the 60, I'm going to do 8 radical 3 because 2 times 4 is 8. Here we have, I can tell that it's a square because I have these notches, which means these are all 13, so that's 13. And since this is 45, 45, 90, since it's cutting a square in half, this is going to be 13 radical 2. The last problem's on the first page. I'm going to use some trig to completely solve. Actually, I can figure this one out in my head. This is going to be 57 degrees because these have to add up to 180. I'm going to call this guy x and this guy y. It doesn't really matter which one is which. To find x, I'm going to use a 33 degree angle, say the cosine of x, the cosine of 33 is adjacent, which is x, over hypotenuse. So if I do 18 times the cosine of 33, I'll get my x, and if you type that in, you get 15.096. I'm going to do the same thing for y, only I'm not going to use cosine, I'm going to use sine, so I'm going to say the sine of 33 is opposite over hypotenuse, so y over 18, and if I do, to solve this, I'm going to do 18 times the sine of 33, that'll give you y, and if you type that in, you're going to get 9.804, which makes sense that this one's shorter than that because it's got a smaller angle. I think I've got my sides, and I'm good. You could also use Pythagorean theorem to get the third one here. The last thing I'm going to do for this problem is, I might as well just use Pythagorean theorem to find this side, so I'm going to do if I call this x, I would do x squared plus 7.5 squared equals 31.3 squared, and if you solve that, you get x equals 30.39. Now I need to find some angles, and I'll call this theta, and I'll remind myself that if I use theta, I'm going to say, let's see, if I was doing cosine, the cosine of theta would be adjacent over hypotenuse, but I want to find the angle, so I'm going to use the inverse cosine of the ratio, 31.3. And if you type that in, that'll give you your theta, and if you do that, your theta comes out to be about 76.14. If you know this is 76.14, you can just do 90 minus that to get your last angle, and that's going to come out to 13.86 degrees, and now you're completely solved. That's the first page.